So what are we going to talk about? So we are going to talk about patterns and how we describe patterns. So how do we describe them? And so one of the ways that we learn how to describe them is with formulas. And so I want to give you this multiple choice question. And it says, you have the number pattern 7, 10, 13, 16, 19. When calculating the nth term rule of the sequence, what should you replace the rectangle with? And all you've got so far is a 3n. And you have to choose which of the four would you choose to go with that 3n. Lock your answers into the chat, please. You might be going back in time a little bit to grade 9 and grade 10 and going, what was that thing again? How did it work? The nth term, it's like Tn is equal to something and something. And if you're like, whoa, I need some help here, like maybe give me an unhappy face or hands down. If you're like, listen, this is too much. I need a bit of assistance. Okay. I want to say that in this number pattern, what is it going up by? It's going up in threes. That's why the number in front of the n is going to be 3n. But if I use this formula and I put a 1 where the n is, if I go T1, I get 3 times 1, which is 3. What is the first term here? Is the first term 3? No. And if I use this formula as it was, if I put a 2 there, I would get 3 times 2, which is 6, which also doesn't match this. So it's almost like we need to make an adjustment to this formula in order to make it fit 7, 10, 13, 16, 19. So what number do you think? If you think of the number 3, that's where you are, and you want to get to 7. What do I need to do? I think that our formula has to be plus 4. So let's just check if this formula describes this number pattern. So I'm going to say T1 is 3 times 1 plus 4, which is 7. So I've got the first term. But what about the second term? Well, if n is 2, the number of the term is 2, 3 times 2 is 6. 6 plus 4 is 10. Okay, let's just check one more. 3 times 3 plus 4, what's that going to be? 3 times 3 is 9, plus 4 is 13. Okay, it looks like I have got a way of describing this number pattern. Which of the 4 options do you think is going to be correct? A, B, C, or D? Lock your answers in, please. Ganlon, Asande, you have locked in your answer and you have said D, and I agree with you because it's going to be this thing over here. Now, just to give you some language, this is called a linear number pattern, or some teachers will call it an arithmetic number pattern. What is the rule that describes this pattern? It says, look, I start at something, I start at 7, and then I add 3 each time. So when we talk about patterns, we have formulas, but sometimes we can describe them in words. And if I describe this pattern in words, I'd say I started at 7 and then I add 3 each time. Give me a thumbs up if this example makes a bit more sense now. All right. Let me ask you one more question. If I had to say to you, what is the next number in this number pattern? Could you type that into the chat for me? What would be the next number in this number pattern? Pop your answer in the chat. Let me know what you think it is. So since we were adding 3 each time, the next number would be 22, then 25, then 28, and so on. So we're going up in 3s. All right, let us go. I'm going to skip the multiple choice now, and I'm going to go straight to this. Okay, these are sometimes number patterns. Another word for number pattern is a sequence. And so you'll see sometimes we use these words a little bit interchangeably. So for each of these number patterns or sequences, I want you to determine the next 2 numbers. So you're going to go for number 1, you're going to give me that and that. For sequence B, you're going to give me the 1 here and 1 here. And for this one, you're going to give me 1 here and 1 here. So basically extend by 2 terms, by 2 extra terms. Okay, so you're going to tell me for number 1, and then number 2, and then number 3. Pop your answer in the chat. So this feels very similar to the last one, because if I look at what the power in this pattern is, it's going up by 3. So if it's going up by 3, I'm going to get 26 and then 29. It's almost like the rule is start at 2 and then add 3 each time. Now, what about sequence B? What do we think is going to happen there? It doesn't go up in 3s. Maybe somebody can help us. This is a tricky one. You put your hand up if you feel like you might have a little bit of a helping hand for us. And welcome to, we have a few more students in the house. Welcome to Bukle, Koketso, Machadiso, Njabulo, Naledi, Onalena, Oratile, Reniwe, Siamtanda, Tenda, Tandiwe. Welcome. It's good to have you with us. Okay, we need some friendly help here. Who's going to help us out? How do we know? I can't go up in 3s, but I'm seeing that goes up by 1. This goes up by 3. This goes up by 5. This goes up by 7. This goes up by 9. This goes up by 11. What do we think the next one is going to go up by? I feel like if I look at this pattern, which is itself, I think I'm going to add 13. And then I guess I would add 15. Give me a thumbs up if my little green bits make sense to you. I'm just being like a police investigator here. Like I'm looking at what are the number patterns that are here. So if I go to what's next, this would be 53, and this would be 68. Now, this feels quite different to the first one. And so maybe we need a different word for describing this pattern over here, but we'll get back to it in a little bit of time. What about C? Buchle, I'm going to get to that. That's a very good question. I'm going to describe all of these in a moment, but for now, let's do for 3, what's my next term going to be? Sometimes it's helpful to think in words. So it feels like from 1 to 2, I double. From 2 to 4, I double. From 4 to 8, I'm doubling. Oh, this feels like every day I'm doubling, right? So like that's the words that describe. And if I double 64, I get 128. If I double this, I get 256. So it turns out there are many different patterns in the jungle. And so each one of these number patterns or sequences feels a bit different, even though each of them has a rule. So let me try and use different ways of describing. Let me use my words first. If I was describing number 1, I would say start at 2. Okay, start at 2 and then add 3 each time. Start at 2, add 3 each time. That's if I was describing it in English. Start at 2, add 3 each time, or add 3 for each new term. Maybe that's a better way to write it. Add 3 for each new term. Okay, number 1. So number 1 is called a linear pattern or an arithmetic pattern. Now for number 2, that's a bit more tricky. So the second one, I would say, if I was using words, start at 4. So I would go like this. I'd say start at 4 and add, how would I say this? And add 1 and then add 2 more than that, add 2 more than that each time. Oh my gosh, what a mouthful. Give me a thumbs up if you understand what I said with my words here. Start at 4, add 1, and then add 2 more than that each time. So I add 3, then I add 5, then I add 7. I mean, it's a long way to say it, but I think it does it. Now, there's something else that's quite important for B. There's something called, in fact, let me do it separately up here. So I'm going to say 4, 5, 8, 13, 20, 29, 40. If I look at the difference between these terms, this is called the first difference, okay? Because it's literally the first difference between the terms. If I go 5 minus 4, the difference is 1. If I go 8 minus 5, the difference is 3. So these are called the first differences. Give me a thumbs up if you understand what I mean by the first difference between terms in a number pattern. Now, it is possible to find the second difference for a number pattern. What do you think the second difference is going to be for sequence B? Can you tell me what the second difference is here for sequence B? So the difference between this and this is 2. The difference between this and this is 2, 2. So what we see is the second difference is constant. Now, this is important. It's almost like recognizing a leopard by its spots. If you know the second difference is constant, you know that it is what's called a quadratic pattern. And so you will have to use the quadratic pattern method in order to work out what this is. Okay, so I'm actually not going to give you the formula right now, but what I am going to say is that when the second difference is constant, like this, then you know it is what's called a quadratic pattern, and the formula will have a squared in it. All I want you to do today is be able to recognize this animal in the wild. So give me a thumbs up if you think you could recognize a quadratic pattern in the wild. Thank you, Asande, Callan, Bufunzo. I see you're all good at spotting the wildlife. Okay, now, last pattern. If I look at this one, I'm going to say start at 1 and double for each next term. All right. Now, if we think about what's happening, we're just multiplying by 2 each time. And so this type of number pattern is called a geometric sequence. If you multiply by a constant amount, you will get a geometric sequence. So far, what have we got? We've got an arithmetic, which was the very first one, number 1, an arithmetic or a linear. We've got a quadratic, and we've got a geometric. Now, I think what we need is another go at this, but let me pause. Are there any questions about recognizing these sequences in the wild? Okay, if there's no questions, then let's see. I want you to look at these next 3, and I want you to generate the next number in the pattern. And I also want you to tell me what type of sequence or number pattern is 4, what type of number sequence is 5, what type of number sequence is 6, and also produce the next number in the list. So over to you, guys and girls. You figure out what's going on there. What's going to be the next number here, and what type of, what is that? What's the next number here? So this would be 21, and this will be a linear or arithmetic sequence. I'll give you more time for number 5 and 6. Nicely done, Tandiwe. Nicely done, Sunako. This feels a bit weird, like it's going up in 1, up in 2. The first differences, I'll just do this. I know what this is. The first differences are going up regularly, which means the second differences must be constant. I kind of know that this is going to go up by 9. So what's my next one going to be for sequence E? So if I'm going up by 8, then this must go up by 9. It's 49. And I can see the second difference would be constant. Like If I did another level, this would be the second difference. And we can see that the second difference is just going up in ones. And so because the second difference is constant, we know this is a quadratic pattern. Okay, what about f? What is the next value going to be for f? What rule? Can somebody give me some words to help me understand what's going on here? It's not doubling. What's happening here? It looks to me like to go from 2 to 6, I multiply by 3. And then I multiply by 3, and multiply by 3, and multiply by 3. I think I'm going to have to just multiply 486 by 3. And what do I get here? What's this final number going to be here? Someone can help me out. It's going to be like 1,000. What is it going to be? Gadlin, you came to the rescue. 1458. And because I am multiplying by a constant value, we can say that this is a geometric number pattern. Okay, now in this unit, we are going to learn about linear and arithmetic number patterns. The one that's going to get the most attention is the quadratic number patterns. And then we'll also learn a little bit about the geometric patterns. And at the moment, all you need to know is that for the linear ones, you either add or subtract a constant amount. For the quadratic pattern, the second difference will always be constant. And for a geometric pattern, you either multiply or divide by a constant. So that's the main ideas that you need to know for now. I will start laying on the formulas as we go, but today we're mainly going to work with linear and arithmetic after the break, where we learn about how to use the TN notation and how that kind of works. So for example, this one over here, the notation here would be, it's going up in twos, so it would be 2n plus 1. So that would be the formula that describes number 4, but there's all sorts of things we can do with that formula. Okay, give me a score between 0 and 10 about how you're feeling about number patterns so far. Mostly, I'm just introducing you to the main characters in the game, but I want to know how you're feeling about recognizing these number patterns. And be honest, because it helps me know how the speed of the lesson should go. Thank you, everyone. I see your votes coming through, and I do appreciate them. All right, before we move on, it's time to take care of our brains. You know that our brains are the most important thing, and so we need to take care of them. So I want you to join me and stand up, and I want you to join me in taking 3 nice deep breaths, because your brain runs on oxygen. So breathe in, breathe out. Breathe in, breathe out. One more. Okay, then we've got oxygen. Now we want to get nice and loose, get all that tension out of our bodies. And so we're just going to start by shaking our arms around like we're one of those things waving around in the wind, one of those display things. So shake up your arm until it's nice and loose. And then I want you to shake your legs, give them a nice shake. Get all that tension from sitting out your body. And then let's do a bit of a twist. So just rotate from your hips nice and gently. Oh, I can hear clicks. I can feel my body appreciating the TLC I'm giving it. Okay, let's just roll the shoulders back a little bit first. Okay, so we've got some oxygen, we've loosened ourselves up, we've got rid of our stress, and now it's time to get the blood pumping. And you know what's coming? It's going to be these guys, what we call jumping jacks, and we're going to do 15 in 3, 2, 1. Let's go. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And that is all she wrote. Give me an emoji to give me some insight into how your body is feeling. Tandiwe is like, why am I jumping in maths class? I didn't sign up for this. I signed up for maths. Well, and my argument would be maths is full of exercise if we do it right. Okay, let's continue. Let's just do these last two, 7 and 8. I want you to find me the next term in the sequence and then tell me what type of number pattern is 7 and what type is 8. Oh, I can feel my heart is beating still. It's catching up. What's going to be the next number in number 7? And what type of number pattern is that? And what about number 8? This seems to be going up. Like if I look at all these, it seems to be going up. Its first difference seems to be 4. Oh, that's another way of thinking about it. If you have an arithmetic or linear pattern, the first difference is constant, right? So the next term is going to be 37. And so we know whenever the first difference is constant, it's going to be an arithmetic or linear number pattern. Okay, what about number 8? What is number 8 going to be like? I feel like this is doubling again. And so that would be 128. So I'm just multiplying by 2 each time. Now, what type of number pattern is this? Where I double things. What's it called? It's called a geometric number pattern. Yeah. And it always has something where you're multiplying or dividing by a constant. Just for extra kind of information, the thing that we're adding or subtracting that's constant, we often call D, or the common difference. And when we have a geometric pattern, the thing that we're multiplying by is often, well, it's called R, and it's called the common ratio. And in this case, R would be 2. In this case, the common difference would be 4. And especially in matric, you'll see that we start using A's and R's and D's. So just bear that in mind. Okay, I feel like you've been introduced to the big 3. We're now going to focus a bit more on arithmetic or linear number patterns. So I want you to try and, using what you've seen so far today, it says determine a formula for Tn for each of the sequences below. So what they're saying now, instead of saying words, start at 2 and add 5, you need to describe this number pattern for me using the formula in the Tn method style. What do you think my formula for this number pattern is going to be? So let's do a little bit of, we add 5 there, we add 5 there, we add 5. So this is definitely an arithmetic pattern. And the way that we've seen it so far is that the way we get the 5s here is we have a 5n. Now, there is another method we could use, which I'll show you now. But for me, if it's going up in 5s, I put a 5 in front. But then I have to adjust that because that doesn't fit what we have. What do we need to, if I put a 1 here, I would get 5 times 1 is 5. I need to adjust something. I need to have a -3. And so the rule that describes this number pattern, if I put like 3 in, 5 times 3 is 15. 15 minus 3 is 12. That's the third term. Now, some of your teachers may use another method where you go 2, where you take the first term, you go n minus 1, and then you times it by 5. Just give me a thumbs up if your teacher uses this method. Okay, so I think in grade 11, this method on the left is what we use. On the right, we normally only use that in matric, but these are actually equivalent. I just like that this goes faster on the left. So just to show you why this is the same thing, if I had to multiply the 5 in here, I would get 5n minus 5. Let me actually show you. So if I went like this, then we would get 5n minus 3 anyway. And so it doesn't matter what method you use, as long as you end up with tn is 5n minus 3. Okay. So here, now using the power of your new formula, I want you to find me term 25. So you've got this formula. You've only got the first 4 terms. What is the 25th term going to be in this number pattern? Use the power of your mathematics. I might need some help here, but I know that I need to decide what goes in here. So who's going to tell me what goes in there? Yeah, it has to be, because this is n, and n comes from that, so it's going to be 25. So the 25th term, what's the value of the 25th term if I kept on going? I went all the way to 25. So 5 times 125, oh sorry, is that? And then I get 122. So the 25th term is 122 in this particular number pattern, right? So if I just kept on going, and eventually I got to the 25th place, I would get 122. Okay, I want to upgrade. What if I had to go to the 526th term? Could you tell me what that value would be? I want to know what T526, or the 526th item in this list, what's its value going to be? I'm definitely going to need some help from some friends here. So I'm going to put a 5 and something minus 3. And again, I want you to think what goes here. I think it has to be this thing, 526. But now I need a calculator to multiply this times this minus 3. And I get 2,627. So this is quite a powerful thing, because I can just work out basically the value of any term once I know the number pattern. So come on, mathematics. Okay. I want you now, this is a negative number pattern. Can you work out the formula for this number pattern. I'll give you some time to think. Think about what the next term is, so you can figure out what the next term is, and then I want you to figure out what is the number pattern that describes it. I suppose I should do some work and ask what's happening here. What's the first difference here? It feels like I'm taking away 4. Taking away 4. Taking away 4. I guess I should take away 4 again, which gives me minus 18. Okay, but now how do I apply this to make a formula? I'll give you more time for that. What formula do you think we're going to need? It's definitely a linear number pattern, Tadiwe. I'm with you all the way to the bank. It's a linear number pattern, which means that we're looking for what's called the constant difference. And the constant difference here is just minus 4. That's the thing that we're taking away each time. So what I'm going to do is I'm going to put a minus 4 in there. The minus 4 is going to do the job. But now I need my balancing term. So at the moment, if I just put a 1 in there, I would get minus 4. But that's a problem because the first term is minus 2. So how do I get from minus 4 to minus 2? I have to add 2. And so the formula that describes this number pattern is this. We call this a decreasing linear pattern. And the reason we call it decreasing is the value is literally decreasing because of the minus 4. All right, I want you to figure out for me what is the 100th term in this number pattern. What is the 100th term in this number pattern? What's T100 going to be? And this is where I love mathematics. It's so efficient. You want the 100th term, you make n 100. Minus 400 plus 2, it's minus 398. Awesome, awesome, awesome. Quick vote out of 10, where 0 is no clue, 10 is I've got this completely, 5 is I've sort of got this, but I need to improve. Where are you sitting on the scale of 0 to 10? Okay. Be honest, because remember that I know where and how to guide you guys. All right. Let's try this one. I want you to do these 3 questions for me as best you can. So here's a pattern. First of all, my first question is, what is this value going to be? Is the next value, what's that? And then I want you to do these 3. See what you can do. And if you get stuck, I want you to raise your hand, and then we'll go from there. Yeah, this isn't so bad. This is an increasing number pattern because it's going up. It's going up in 4s. The constant difference, or D, is 4. What's my formula going to be? So I know I need a 4n because it's going up by 4s, but now I need my balancing term, or what we call the constant term. And my first term is -1. At the moment, I end up with 4 if I put 1 in. So I actually have to lose a couple of numbers. And so I'm going to go, this is 4n minus 5. So let's try and do B and C together. So I'm just going to use my hard work over here. So the 50th term is 195. Now, the last question is a bit different. Can anybody tell me how it's different? Like, how does it look different? What is it? I don't think we've done a question like this. Can you give me some tips? Like, can I still use my formula? Where do I put the 403? That's what I'm going to ask you. Where there's this, it says which term is equal to 403. So tell me, where do I put the 403? So I've got my formula. I don't know what n is, but I do know what the value of the term is. So I'm going to suggest that I make Tn 403, and now I need to solve for n. So basically, this 403 has gone here. So now I'm going to add 5 to both sides, and I get 408 is 4n. And then I'm going to divide both sides by 4, and I get n is 102, which means that 403 is term number 102. And I can see a Sunday and Buchle agree with me, and so does Sinako. Are there any questions about how I did that? Or just give me a thumbs up if you're happy to move on. Okay, I see the thumbs in the air. Let's do another one. Let's do this one. You find me this value over here, and then you do the next 3 for me. See if you can figure out the answers to these things here. Okay, now what's going on? This one is -1, -1, -1. So this is going to have to be 0. The constant difference is -1. So it's a decreasing pattern. But I'm feeling a bit more confident now. Like, this is going to be -n, but it's a bit tricky to know what number comes with this. Because if basically at the moment I'm stuck at -1 and I need to get to 4. So what is the journey? Okay, well, I can go +5. So this must be +5. So that's A. What is T32 going to be? Well, the beauty of having this formula is that I think it can do most of the hard work for you. So if I want that, I know I go minus 32 plus 5, which is minus 27. So the 32nd term is the value minus 27. Okay, now using the method that you saw before, which term equals minus 44? Remember, we're not saying n is something. We're trying to work out what is n such that the value of the term is minus 44. So the key step is to replace this with that value. That's the thing I'll end up with. What n does it come from? So if I move this across, I get n. And if I move minus 44 across, I get 44 plus 5, which is 49. So T49 is equal to minus 44. All right. So we notice that there's four types of questions. There's tell me the next value in the number pattern. There's find the formula. There's use the formula to work out a term in the number pattern. And then there's the work backwards question. These are the classics. They will always ask you this in grade 11 and in grade 12, to be honest. And so that's why it's good for us to practice. Okay, let's do another one. I think this will be our last one for today. See if you can do what's the next number, and then can you do these three here? So that's 18. We can see that D is 4. What's the next one going to be? I'm starting to feel like there's a bit of a pattern to these patterns. So now I've got 4, but I want to get to 2, so I go minus 2. What is T18 going to be? So this is my tool for the job. I'm just going to put an 18 here. That's 72 minus 2, so that is 70. So the 18th term is equal to 70 by using this formula. Okay, what about this one? Can we do that one? So if I put 114 equal to this, then I need to solve. So the key step was to take the 114 and put it here. And now I need to solve for this. So I get 114 plus 2 is 4n, or 116 is 4n. And then n divided by 4 on both sides is going to be, so T29 is equal to 114. All right. We will continue with this in the next lesson, because we can get some more advanced ones. But I think for today, that's a good place to stop. So let's talk about the main ideas. We recognized 3 different types of number patterns: the arithmetic or linear number pattern, the quadratic number pattern, and the geometric number pattern. The arithmetic one we focused on a lot now, and the key idea with this type of number pattern is we always have a constant difference, which is either a positive or negative number, and then we use the TN notation to describe it, and then often we have to figure out a number using the formula, and then often the last question is we work backwards. We might have some number like 512, and we have to work backwards with our, let's say this was 3n plus 5. Often, if we need to figure out what term in the number pattern was 512, we would do something like that. Okay, in future lessons, we will talk about quadratic number patterns and geometrics. But that's it for the main part of the lesson tonight. Give me a score out of 10 for how you feel about this content. After today's lesson, how do you feel about this content? Awesome. Thank you for your votes. They are helpful in keeping the class moving in the right direction. Now, I just want to finish today. Those of you who don't want to stay for extra question time, you don't have to stay. But there's one extra question that a student has submitted that I want to go through. Who can tell me what topic this is from? This is question time. This is the bonus time. What topic is this from? Today's student questions. This is Euclidean geometry. Yes, Euclidean geometry. And often in grade 11, it focuses on circles. So the quality of the photo is a bit bad, but what it says is the angle at the center is something the angle at the circumference. And the correct answer is the angle at the center is twice the angle at the circumference. Often this shape kind of goes, it looks a bit like an arrowhead. And so we would say this one over here, if this one over here is 2x, that one over there would be x. The angle at the center is twice the angle at the circumference. Okay, so that's the first bit. Then the second bit says the opposite angles of a cyclic quadrilateral are, we would say, supplementary. So if you have a cyclic quad is a quad where all 4 vertices are on the circumference of a circle. So that is a cyclic quad. The opposite angles in a cyclic quad would be like those 2 sets over there. And in this case, what we're saying is these 2, the x and the y, they will always add to 180 when it's a cyclic quad, and the b and the a would also add up to 180. Okay, so that's what I would call bookwork. Then the actual question, and maybe I should draw this so that you can see it a bit more clearly. There is a circle, and on that circle there is a cyclic quad, and the letters are A, E, N, and C, but then there's also an O in the middle. And then what happens is there are chords that go to there and to there, and to there, and to there. And then there is radii that go from O to E and O to C. And then there's another line that goes from the one side. So this would be a chord. Apologies that it's a bit dodgy, but that chord goes from there to there. And then there are these little arrows. What do these arrows, this really doesn't, I didn't draw the scale well, but these arrows, what do they mean? Yeah, we have parallel lines here. Yeah, we have parallel lines. Okay, now it says also A1 is 32. So what they say in the question is that this thing up here is 32. Now, I've drawn this a bit wrong to scale, but basically that line over here should be parallel to that. It's just that I've got my scale a bit wrong, but you're going to just believe me for now when I say it's parallel. So the question says, what is the size of COE? Oh, sorry, COE. COE. Okay, here is COE. It is over here. And but let me use COE, angle at the center. Okay, so let me go backwards. Let me rather use the blue that I had here. So this angle over here is the angle at the center, and then this one over here is the angle at the circumference. So what we know is that COE will be 64. Give me a thumbs up if you understand why the big blue dot is 64. Okay, so that's, and now when we do circle geometry, we need to give some reasons. So what we do is we're going to say angle at center is twice angle at circumference. Angle at, sorry, apologies for the handwriting, but you get the basic idea. So this thing over here is 64. See if I can get that right. Okay, 64. Now, where is E2? Okay, E2 is this thing up here. And we can't really see this, but basically these lines are parallel. So that's going to be 64 as well, because it's basically, these are parallel, even though they don't look it. And so the reason would just be alternate angles. And then it's between the parallel lines AE parallel to OC. So those two are 64 and 64. Give me a thumbs up if you understand where that 64 came from. Okay, now OCE. OCE, where does that live? OCE. OCE is down in this corner here. Now the thing is, these two things here are radii. All right, let me move. I think can you guys see it okay here? Can you see? Maybe I should just move it up a little bit. So basically, what we have is these two, this thing here is a radius, and this thing here is a radius, which means these two angles must be equal. And OCE would just be 180 minus 64 divided by 2. So who can work that out for me? What is, because you know that's 64 there, then because these are two equal angles, what are we going to get? So Puvunzo, I'm trusting you that that is correct, 58 degrees, but now I need to give a reason. So the two reasons I've used are sum of angles in triangle, and I've also used the reason angles opposite equal sides, or we could have said radii. So what we then know is that this is going to be 58. And in fact, both of these are going to be 58. All right, now, last thing, n. What is n? N is hanging out down here. What do you think n is going to be? I'd love the audience to give me a suggestion. What do we think? I think there's a theorem that has a relationship between this side and this side. I think, let's add 64 and 58. What do we get for 64 and 58? 64 plus 58. It's 110, 122. So if that is 122, if I've done my maths correctly, these two together have to add up to 180. So this would just be 180 minus 122, which is 58 degrees. So this is going to be 58. What is my reason going to be that supports the 58? What is the reason going to be that tells me about the relationship between these two? It's just going to be opposite angles, cyclic, opposite angles, cyclic quad. Opposite OPP dot angles, cyclic quad. Because they told you this is a cyclic quad, therefore these must add to 180. All right, everyone, that is our very first question time bonus thing. I loved this question. This was such a good question. So I look forward to questions in our future lessons. And yeah, I think we're going to wrap it up for tonight. Any final comments or statements?